Hello, everybody. Welcome to our webinar today. I'm Dan Mitchell. I'll be in the background for much of this webinar today, but we have Peter Papageorge hosting with Sean Murtha covering technical aspects of our webinar today, which is Televic Advanced Integration Features. Some notes about the platform before we get started. It is preferred that you use the browser Google Chrome. So if you're not currently in Chrome, you may have a limited experience or not have great quality. So if you have time to switch over to Chrome now, if you're not already in it, that would be ideal. Some notes about the platform itself. Off to the right-hand side, you should see a white box that has some different tabs on it for questions and chat. As we go through the webinar today, feel free to chat in the chat box if you have questions or put them in the questions tab, whichever you prefer. And we may throw some polls at you just to learn a bit more from you as well. With that said, I will throw it over to Peter to get us started.
Great. Thank you, Dan. Just make sure you can see me and hear me okay?
Yep, we got you.
All right, great. Thank you. So thank you for joining us, everyone. We have a diverse group today from around the world. We have a number of consultants visiting us today, dealers, end users in some cases, and our sales teams from around the world. So thank you for joining. Today, basically what we're going to be doing is talking about Televic and how we can expand into the world of design with DSP. So we're going to take some liberties on shortcutting a few things. We're going to do about a 30 to 40-minute presentation with time for questions. So let's dive off before I hand it over to Sean for the main part of kind of diving into the back end. Again, for a lot of you online that maybe not have followed Televic over the last few years, we have grown actually close to, I think, maybe over 1,000 employees now worldwide. We have direct offices in the U.S., 7 of them warehousing on both coasts with support and all of the necessary engineering capabilities for design and capable. But again, our history for large scale is something that many people know in some regions and some do not. Everything from NATO doing all 5 buildings, having people stationed at NATO permanently, in addition to large institutions, but also here in the US, State Department, White House, a large institution is multi-language. But I think a big part is where we've evolved because of COVID and also because of our purpose built. So today we're going to talk a little bit about not the customers pretty much, but the installations. And also because our category has become more valuable because of COVID, because people need the flexibility to meet safely, hook up to Teams and Zoom, whether it's wired or wireless. So the discussion microphone became very important over the last 12 to 18 months. So today we're going to dive into the map of our topology of the Plexus network. Plexus is the name of our architecture that everything is based off of for the last 4+ years. But we're going to dive into the audio aspects of Dante and DSP, different modes and capability, also the control aspects, and also video. A number of people are unaware of Televic's capabilities with video. So, I'm going to shortly go through the generalities of this, but we're also going to talk a little bit about new hardware and software platforms because it all comes together, not just for the design with consultants and integrators, but also the end user flexibility. In a general sense, just before we kick it off, everything in green is the Televic world. All standard shielded Cat5, not proprietary, but must be shielded. So I think the main thing is making sure that whether it's wired units, it's flush mount or desktop, or it's wired and wireless combined, with or without interpretation up to 40+ languages, and also video. I think what's interesting, people find out we have video devices and they go, well, how does it work? We're going to talk about that today. In the gray area, ultimately, we're looking at the world of AV integration without Televic. We use DSPs, we use control, we use video systems, whether it's BiAmp, QSys, or other related DSPs, or it's SPSI or other video systems worldwide, or it's AMX, Crestron, Extron, doesn't matter. And I think that the number one thing in the history of the conferencing category, as Televic is in, and all of our competitors, a number of people always looked at this as Televic does one thing, and when you need that, that's when you use them. Well, it's much different now, and that's what today is all about. So we're going to dive into that. Also, with the expansion of the new hardware, if you haven't seen Televic in a while, I think you'll be pleasantly surprised of new audio formats, wired and wireless, video formats, not just flush mount and tabletop, but we're going to talk about that, and also customization, being able to provide a number of solutions. So let's dive into a couple new things that you may or may not have seen. Our audio unit on the left and our video unit on the right. We're looking at our new Flex series of audio. And what's nice about this, it's a license-based piece of hardware. So when you're designing something, you don't have to worry about, did you buy a chairman and delegates? Did you get the ones that have voting or not? It's one piece of hardware and is assignable. So I can make these units hardware, whether it's wired or wireless. I can make it a delegate, a chairman. I can add on features later on as a license, so I can tell the customer we can upgrade you later and you don't have to change anything. So not only seeing the touch screen on the wired and wireless design, you have a microphone button that's assignable per the designation. When it's a chairman, you have two LEDs on the mic button, one for your mic and one for mute all. When it's a delegate, those LEDs go away and there's an LED in the middle that says this is your one big microphone button. RFID card inserts for different applications. We have touch panel with actual haptic response. When you touch it for voting, it vibrates, so it gives that confirmation. Tactile references. And I have to tell you that the low profile design of this product is amazing. When customers see it, you're going to be very impressed with not only the build quality, but the ergonomics and low profile. So again, we're winning a number of awards. When it comes to wireless, I think it's really setting the tone. A number of people on the call know of our G3 series. It did not go away. It is still very popular, especially, well, around the world, frankly, but in the US as well. And G4 is complementing it. So we have two wireless systems. The nice thing about the G4, the low profile, as I mentioned, we can take one of these units and put them back to back and slip it in the same slot in a case as one of our competitors. I mean, so you think about flexibility for rental and expansion. But for installation and ease of use, divided rooms and flexibility, you'll notice the sleek design of not only the actual unit itself, but the battery charger. 10 batteries in one RU ready to go, and in 2 hours for a full charge from a dead battery. The access point also has Dante capability. It has your balanced Phoenix connector ins and outs, and a built-in audio recorder. So lots of things that we can go on through another time, but we'll go through that. And also the design that says we'll give you 2 batteries of 12 hours each, giving you up to 24 hours. So that's the crash course on the hardware of the new design for audio. Multimedia, however, though, has, because of COVID, given us a new design concept for corporate applications and other unique things because of what this all has in it. The unit on the right-hand side is the Unicast tabletop unit. We've been doing flush mount for a number of years, and when the tabletop unit came out a couple years ago, it did receive a lot of good direction because of our traditional aspect of what we do, meaning I need agendas, I need voting, I need documents, I want to see who's speaking, request to speak, and I want to see one of those 6 high-def video streams that we're going to talk about in a moment, how we can switch. But something happened because of the built-in webcam, having a microphone, a speaker, a built-in webcam, and a touch panel, and this folds all the way down like a reverse laptop. So this application is a good example. In this room, it was purely audio and video support. We want to be able to say, here is a room that has nothing to do with conference recording in general, no more agendas and things like that. It's not being used. But what's being used is a clean way to have an all-in-one unit to be able to say, I have a microphone, a speaker, and when I hit that button, not only can I see whatever video feed you send it to me, I can actually click on it and the webcam shoots me, sends it to all the units in the room and to the far end, Teams, Zoom, whatever is being discussed nowadays. In fact, what we're going to discuss today is the DSP relative modes and the flexibility that we can do. In this room, for an example, we can take every microphone individually out, separate Dante channels, go out to a DSP, process them, and send them back individually to speakers, pretending that those speakers are in the ceiling, very much like a traditional DSP design. So again, following the expansion of our units beyond the traditional conference is kind of what we're talking about. One last thing on hardware before I hand it over to Sean is the flexibility that Televic has done for many, many years. What's interesting is the flexibility of customization, seeing the things that have been done that can continue to be done. And again, all you have to do is ask. Biometric fingerprint sensor, if somebody says I need that to log in, it is available. Different sizes, shapes, even the color buttons for Italy, providing the colors of their flag on the buttons themselves, adding more ports, whether they're USB, HDMI, HDMI, or an actual structure, because the dais won't account for the angle, will make the angle for you. More importantly, as we expand kind of down this entire topic into other verticals, I think about education and universities, rethinking the way the topology of a lecture hall may be. So now where I can work with furniture manufacturers to put a microphone in a seat, a speaker in front, and maybe add in things. But all I'm doing is a standard shielded Cat5 connected with the DSP gives me much more firepower for different things. Even handheld microphones, to be able to pull out from a seat and say, I must stand up, or have a mic on our system. And we'll talk a little bit about other audio capabilities. So I think we're going to jump into it. Sean, if you can take over from here, let's jump into the audio side, the back end of Plexus, and how we route and what it does. So if you can take it from here, that'd be great.
All right, thank you, Peter. And as you said, we're going to talk about some of the ways that we can handle audio, right? We're looking at a system that is scalable from, a dozen microphones to literally hundreds of microphones. In the past, with most conferencing systems, you would get a feed of everything. So whoever turns their mic on, or several people at the same time, would just be part of a floor audio feed. Some systems have had the capability to make certain groups, but that's usually been the extent of it. We have taken it a bit further than that to help give you some more flexibility with processing, so that you have the freedom to decide what you want to do with our system and how much individual control you want, all while maintaining the same daisy chain shielded Cat5 topology without having to home run everything. So next slide, Peter. So first thing we want to look at is, what does our audio routing actually look like? So we've got a grid router that's not unlike Dante Controller or lots of the other ones that you guys have seen. But I wanted to make a couple of screenshots here and show you what certain routes might actually look like in the back end. So in this case, what we've got along the left-hand side, we've got each seat, right? Each Televic microphone can be broken out into an individual node. Then along the bottom, we can have our various outputs. These can be Dante outputs. These can be channels that are available to listen to on our system. These can be analog outputs, etc. And this is kind of the simplest form, showing, well, how do we get a discrete microphone out to a discrete Dante channel? Well, this is how we simply create these nodes and do them in the back end, up to 64 channels. With Dante, if you get into a system that's beyond 64, it's usually pretty easy to group, 2, maybe 3 mics into a zone as well. Next slide, Peter. So what does the mix minus look like? So this screenshot looks pretty similar, but it is a bit different. Next slide. So we've created nodes again, but this time we've created small groups, right? The previous screenshot just showed each microphone as its own node. Here we just have nodes that's everybody except you, right? So that's what you see with the labels there. So seats 1 and then 3 through 10, seats 1 and 2, skip seat 3, go 4 through 10, etc., like you would be used to with mix minus. Then along the bottom with our nodes, rather than doing Dante output as we did before, we have each unit as a destination. So each unit's onboard loudspeaker is a routable destination. So now we've created our groups, everybody except you, and then send that to your speaker for a true mix minus. We're even going further, and a little bit later this year, we're having a more advanced integration of this that shortcuts having to kind of go through and even make this matrix. There's more of a kind of automatic way that's going to be coming. Next slide, please. Then this screenshot is just kind of fun to show. It's a picture of a real world installation where you've got a lot of different multi-channel audio happening with a lot of different destinations. This happens to be one that deals in the interpretation world. So we're carrying multiple different language channels over our cable, and we're sending them to all kinds of different places. You'll notice that in addition to the green nodes that we saw before, we've got some orange ones as well. The orange ones are kind of a backup node. With every node, we can set a kind of fallback channel. So if nothing shows up on the first channel, it will default to the backup. So that's basically what you see with the green and orange. I don't want to get too bogged down with exactly where everything's going on here, but this is more of a just a way to show a lot of our audio routing flexibility.
So Sean, also, I think that there's a lot of discussions about court systems, especially in the U.S., because of how we interface or how the court systems designs need to interface with FTR or CourtSmart or Liberty multi-channel software. And it is top of mind for the engineers at Televic, and that's why when Sean says what's coming, we're showing you what is right now. I think the nice part from a design point of view is know that we're working towards other features and capabilities like true mix minus or DSP mode, where our product is really more of a component. Here's a bunch of mics and here's a bunch of speakers. What do you want to do with it? But courts, when it comes down to whether we do a lot in language interpretation worldwide. In the States, maybe not as much, but we need multi-channel in courts, and we understand that all of those channels need to be diverted to the recorder, even during sidebar, even during different types of scenarios of things in the courts, or whatever corporate applications and interesting things you need to do. So we wanted to share with you a little bit of what we do now, and many people don't even know we do this, and that's one of the reasons for the webinar series. But know that it's continuing to expand, and we encourage anybody on here to contact us directly and say, this is great, we need to know if you can do this and where you're headed, because our hardware can work within your design. Okay.
All right.
On real quick, a great question came up from Adam. He's wondering whether each microphone requires its own Dante channel or if they can be summed into one channel. So maybe that's an opportunity to talk about grouping mics together, individual channels, or just a sum of all the mics.
Yep, go ahead, go back about 3 slides, Peter. There you go. Okay, so you don't require a dedicated Dante channel. It's really up to you how many individual mics you want to show up on individual Dante channels. For instance, right, let's say we wanted these seats 1 through 14 to all just go to Dante 1. Rather than having that green line going in a diagonal where it goes to a different Dante channel, if we just went in a straight line and just connected the green dots straight down, they would all show up on Dante channel 1 or anywhere in between.
So this reminds me, great question. When I was talking to an integrator that did do a design with our products, and he took individual mics out, processed them, and sent them all back individually. It was a great lesson that I think for us that says, why did you do that? Number one is, well, because that's what we do with DSP. But the feedback was, this is so good to know that you can do this, that in a future installation where I need groups of your microphones, where, you know what, I'm still going to use DSP for other things, but it's not going to be as dependent with the local speakers that you give us. But if I have a row of microphones that I know are above a zone, I can grab all of those on one Dante channel, do my processing, send it back, and then individually or groups, you have total flexibility. So hopefully that answers your question. Okay, and back to here, sure.
All right, thank you. So yeah, what Peter was alluding to, this is just a screenshot from one of our firmware releases that's going to be upcoming, but it shows the advanced audio section with some of just the preset buttons that you can do in there, right? There's bass cutoff, there's an ability to always have the speakers active. There's the little checkbox for to basically just turn the mix minus mode on so that those routes that we showed will automatically be configured. And then we have a little checkbox that's microphones are always active. This is also something that's going to evolve into a push to mute capability, like a lot of courtrooms. Again, Peter alluded to courts, like a lot of courts want, where they want everybody live, but maybe they want to press and hold to just do a temporary mute. So we're going to be rolling that in as well. This is a lot of these things that we're talking about, right, are different from the traditional conference microphone space. Most other people that do this will typically resist all these other different ways of making the system operate, but we've been getting the requests often from all over the country saying that you guys need the ultimate flexibility. You want the control. You want to make the decision as to the best way to handle all of our hardware and all of our audio sources and destinations. So we're listening and we're rolling it all in.
Right.
So that being said there, I think we're ready to move on to the video aspect.
Yes, we are. All right, let's dive in this part.
All right, so we're looking at that Plixus network map again. I've kind of highlighted some of the portions that are showing the video. As Peter said, we can have up to 6 full HD video streams with less than 1 frame per second of latency, living on the same shielded Cat5 cable that's also carrying all of our control data, voting data, and 40 channels of multi-channel audio. So pretty nice to be able to put that all on the same backbone. So let's take a look at what it actually looks like to deal with the video on our network. Actually, before that, a couple more highlights too about what the video is. It's JPEG 2000 that we're using. So if those of you who are familiar probably know that it's become, it has been and continues to be one of the more popular standards that are chosen, right? Every image is fully described rather than just waiting for a keyframe to come about. So it helps improve our quality. Again, less than 1 frame per second latency. Our system also is going to be doing automatic resolution detection through any of the sources that you're feeding us, with all of the kind of definitions listed below. We don't have 4K, as a lot of you are probably familiar. When you're dealing with a screen the size of ours, 7 and 10-inch screens, 4K is generally not needed. So we still live in just the regular full HD mode, but I think you'll find that that suffices quite well.
Oh, you know what, Sean, too, is we don't have it in this presentation, but for those of you that say you have a customer, which you will, we have a number of people that like this and they say, wow, we love this, but we don't have we need more, a screen larger than 10 inches. So we have something called Unibox. Unibox is the piece of hardware that goes underneath. It's the electronics of this, and it goes underneath your table with the Cat5 in and out, and then hooking up an HDMI and a USB to any size touchscreen, generally speaking, that you decide. So if it's one of the motorized screens from Arthur Home, or it's a larger, 23-inch panel because the customer needs that, you can do that with our topology. So know that you have flexibility. Let's dive into the video routing matrix, Sean. How does it work on the back end?
Real quick, Sean.
Yep.
I don't want to lose it. We were just talking about the video specs. Adam asked another good question. Is the video compressed? And if so, what is the compression rate?
So it's going to be, right, it's getting converted to the JPEG 2000 standard, right, when it gets encoded. I'd have to look at what the compression rate of JPEG 2000 is, but I believe that's the question, right? It's not getting compressed further than that.
Well, you know what? Grab Adam's contact information, please, and we'll get back to you, Adam. Good question.
Okay, so back to what does the matrix look like? What does the routing of video look like? So very kind of similar approach to how we handle the audio aspect of things. Next slide, Peter. So I mentioned there's up to 6 full HD video streams available at any given time. What does a stream mean on our network? This is an active video feed that can be pulled up from that Unicast multimedia device at any time. If you've got more than one stream active on the video section of that, you'll have a choice along the bottom of which of those streams you want to be watching. So you pick how many streams you need, and you just put a check mark underneath them to activate them. You can also put a small title with them to kind of tell people what's what. And then what do we decide, or how do we put stuff onto those streams? So we have input groups along the left side. There's several input groups, right? When you're starting out with the basic system, you're always going to have the SDI input that's on the back of our engine available to you. You're also going to have webcams, the webcams of the Unicast units available as well as individuals, or you can group them into different talking head groups. And then if you have our video in boxes, which are daisy chainable boxes with HDMI inputs on them, they'll show up here too. So that's how you get everything into our system.
You know what, let's go back. We might not have explained that. So you notice the topology of, the shielded Cat5 goes in and out through, looped all the way back to our engine through extenders, power supplies if needed. And by the way, don't spend more than 30 seconds trying to figure out a design. Hit us with the specifics. We'll provide a bill of materials and drawings if necessary. But you'll notice that a line goes to this inbox. So the inbox and outboxes are pretty much just another device on our system. And it's implying that you just say, plug it in and through to the next thing. And this orange line is an HDMI. So this is like a lectern concept. That's the most popular. Everybody comes up to the lectern, plugs in their computer. Now that's one of those video streams that you can pull up on our device. Same thing anywhere else. How many inboxes conceivably could we have on a system, Sean? Is that open-ended?
Yeah, it's open-ended. You could do over 100 if you wanted to, but you can only be viewing the content from up to 5 at any given time. But you can group them into different groups, like you could put 1 through 20 You can also add a USB connected, what we call a share button, to them. So everybody can be, you could put 20 video inboxes on one stream. Anybody could walk up to any of them, plug their HDMI in, hit the share or go live button, and that's their video would take over the stream. Then if somebody else were to go in and do the same thing and hit their share button, they would take over.
So then the same concept of the outbox is anywhere along the line, you say, I need to drop a projector at the end of the room, a series of 5 panels in the hallway, you just drop an outbox, and where we're talking is how you route it. But the concept is what's new. And that's why from a design point of view, and we talked to a number of people that are designing systems, is I didn't know you could do all of this. And I said, right. And it's not that our systems are replacing an SVSI video or any other system. It's not. But it's providing a total idea of an easy solution going, oh, if we can move video around and in light video applications, this is interesting. So depending on your customer, depending on the application, and then again, when they start to look at our appliances, you go, oh, we can do a lot with this. So back to, I think, here. So that we were talking about input. So when you said an input of an inbox, you're just dropping inboxes here. Is that correct? You add and there's an inbox that pops up. So whatever you name that inbox, the PC on the lectern, that's going to go, to various now outputs. So that's the next step, right?
Yep, and another note too, right? The inboxes don't have to show up as individual items. They could be grouped when you're creating them. So you could say, hey, this is the front row. If you had a whole row of people that had an HDMI cable at them, so that any of those units, whoever hits their button, could show up there if you wanted to, or they can always be broken out individually too.
Okay, great.
And the same thing kind of applies to the far side, right? Where are we going to send those different streams to? And this is mostly dealing with our outboxes. If we're going to send something to a dedicated outbox, or maybe to one of our interpreter consoles that has HDMI outputs on it, or if you're going to kind of force a feed, this is one way that you could force just a feed to one of our multimedia units. We'll also show you other ways to do that.
Great. I forget we have an international crowd today, so let's jump into that real quick too. What's unique about our interpretation consoles on the same shielded Cat5 topology, but you'll notice there's an orange line here. And what Sean was basically saying is an output from our actual interpretation console. And yeah, you can actually route the video so that wherever the simultaneous interpreter is displaced, which they get displaced all the time, instead of running a separate video system to them, for actual monitoring the room and the people talking, you can literally go, no problem, just get an HDMI version of a video unit enabled Televic ID console and just plug in any panel to it, and ultimately there's your video feed. So very flexible from that side when you need simultaneous interpretation. So I'm sorry, Sean, anything else on this slide?
I think that about covers it for the video routing.
Okay, cool. Video, there's other things. So let's talk about camera.
So the video kind of segues into camera tracking. So a lot of times you're going to want robotic pan tilt zoom cameras in the room for video support, kind of regardless of if you're using the onboard webcams. It's pretty popular to have an automated camera tracking system. So there's kind of 2 ways to tackle that. The first one that we're going to talk about is with a all-included integrated Televic solution. So next slide. And that is TCAM. So what TCAM is you can get anywhere between 2 and 4 pan tilt zoom robotic cameras. They're OEM Lumens cameras for those who are curious about it, as well as we use some Blackmagic switching hardware, video card, and our TCAM software, but we've got it all kind of embedded into a package that communicates directly with our engine. So you don't have to do a bunch of back-end programming to make everything happen. You basically will use our TCAM software to tell the system how to drive the cameras. So what does that look like? The TCAM software that you're looking at here has 3 sections. So on the right-hand side, we've got kind of a geographical representation of where the microphones are in the room. So what you do there is you can either turn the mic on in the room or go ahead and just click on the microphone with the mouse. Once you do that, you will then go to the next section. Peter?
Oh, sorry. Thank you.
You will then be able to steer the camera to a preset A, your primary, and as well as a preset B, a secondary, should your primary camera be in motion or something when someone's microphone goes live. So you fine-tune your shot there, and you hit the save button and go ahead to the next section. And what you're seeing also above is a preview window that's showing you kind of your shot as you're lining up. So that's kind of the process. You select the microphone, steer your camera where you like it, save preset A, go ahead and steer a second camera to it as a backup preset, save that as well. Then the camera system automatically knows that when a microphone or when that particular microphone goes live, to go ahead and send a camera to your pre-selected shot. So in a nutshell, that's how the TCAM works.
So before we go to the next way to do it, it's interesting how many people in various markets, and everybody knows that cameras are sought after nowadays. When people heard that we have a canned type solution that works with our button push, we are using our APIs from our microphones. So when you press it, it sends a command and does its thing. Many applications that normally wouldn't maybe consider a full-blown video solution have tilted towards TCAM because of the ease of use, flexibility. So again, this is not necessarily to replace a video system, but know that it's another way to do it depending on your application and also the end user. The other way is, again, how we've done it for years. So go ahead, what is this from? This is using a third-party system?
Correct. This is using a third-party camera system, so something other than the Televic TCAM solution, which is perfectly doable as well. And this will also kind of segue us into the API discussion. But you get a unique command string for every microphone's off and on commands. If you want to use your own camera system, simply receive our APIs from our engine, which is exactly what TCAM is doing. So, okay, I see microphone 1 is on, and then you use that command to send a preset trigger to the camera system of your choice. A lot of people will use like a Crestron system, for example, to kind of be the intermediary between it, but there's a plethora of different ways to do it. But if you use this approach, that gives you the freedom to choose from the whole wide array of camera systems that are out there, or possibly tie our system into an existing camera system.
And there's also the evolution of the Dante using audio, meaning however you design your information. We've had some people actually take our systems out, separate channels out Dante, correct? And then they're using that audio trigger?
Yes, thank you for that, Peter. There's also some camera systems that are on the market that are using they're using audio, right? An audio source to follow along or trigger where the camera needs to move to. Well, we can help shortcut some of that guesswork out of some of the camera systems out there by sending, like we talked about a little bit earlier, by sending each microphone to its own Dante channel. So some camera systems can say, I see audio showing up on this Dante channel. I know I need to go to this preset now. So that's kind of another way to do it.
Great. All right, last section, APIs.
Okay, so what do some of the APIs look like, right? So here's the API little icon in our Plexus network map.
And by the way, before you jump into there, it's amazing that, and we're going to see a little bit of some GUIs and some browsers and things, and we have a lot of capabilities. But we're back to what the design of a DSP type traditional system is. So we know that everybody uses different things. We want to make sure that you have total access. So regardless of what control you have, it's pretty much a pretty comprehensive document that we give you.
Yep. So speaking on that, our APIs right now, it's a 152-page document that has all of the different options available in it. Virtually everything that you can do with our CoCon software can be driven from APIs. So it could be driven from your own custom designed interface should you choose. So what does it look like when we're actually driving something with an API command? What are you seeing? What are you sending, etc.? So we've pulled just a couple of samples out to show you. So one of the popular things to do is to have like a trim or a sensitivity adjustment, -12 to +12 dB over a particular microphone. So you have a speaker that's leaning back or somebody that's on top of the microphone. Well, I want to be able to control their volume individually, but I don't want to go into the Televic software to do that. So what is one of the streams look like? So this is just a snapshot right out of the manual. The thing that you want to look at right there is the last line, the REST JSON example, right? So this is showing you how to update the sensitivity of seat ID 1 by -6 dB, right? So you can create your own slider that has multiple touch points on it. And you send that command string to our engine, and it will adjust to the sensitivity of that particular microphone. So another one that we grabbed out of there was individual voting results. So this is popular when you're dealing with a lot of legislatures and things like that. We do have voting buttons available to us in the system. A lot of legislatures have their own, whether it's a Jumbotron or Lightboard or all kinds of different solutions for displaying how your representative voted. So how do we actually see the individual voting results? So you can send the you can be listening to the system to hear the voting results. And again, down near the bottom, you'll see what the voting results were. And here's just a snapshot of how delegate 24 voted. They chose voting option 2, which would be abstain in this case. But you would receive a long string of this information once a vote has concluded, so you can quickly say, okay, we know how all these different positions voted, and you can populate the signage of your choice. Again, if you don't, this is if you don't like kind of the Televic software approach, or you have your own kind of custom type of interface. So this lets you take it and take full control of that data and display it how you like. So
what is this one?
So this is another cool one. We talked about forcing certain video feeds to our multimedia units, right? With our Unicast touchscreen units, by default, you've got lots of different tabs along the top based on which features you decide to activate, and people can navigate around. If you have multiple video streams, people have the ability to pick between what stream they want to watch at any given time. But let's say there's periods of the meeting, or in some cases the entire time, you don't want people to have control over what they're looking at. You don't want them to click away. You want this to be a video screen that you are driving. So that's what this command is, a sampling of how you can lock a certain screen into place with Unicast. So if you were to lock in video stream 1 at full screen onto a Unicast unit, that's all everybody would see. If they went to interface with the touchscreen, it wouldn't do anything until you unlocked it.
So there's, I was going to say, it reminds me of a conversation yesterday. There was a corporate application looking at the Unicast tabletop unit and said, you know what, we're just going to have a whole video system switching everything else, not yours, just, but we want to send you that feed. Can we lock that feed onto the screen? We're not going to use anything else. We're using the Televic tabletop as an appliance. It's a monitor, webcam, microphone, speaker, all in one, ready to go, and we'll send it what we need to. And this is the command. If they wanted to change it, we can force our unit to just stay there too, correct? But this is a way to use an API and a button going, all right, everybody, pay attention. We're going to this, video, boom, and you send it all there. You can do it that way as well. So it's either or.
Yep, absolutely. And then just another small sampling of an API that's popular too is, how do you turn a microphone off and on? Right, a lot of people might want to have a list or a kind of their own seat map of the room that they come up with that has icons or ways of turning mics off and on. Well, this is what the command strings look like for you to turn mics off and on from your control system.
Great. All right, thank you, Sean. Just so you know, too, in the U.S., for those of you in North and South America, we have support from the U.S. We have great distributors up in Canada for that, and down in Latin America, we have a great team as well. But again, all of the above, any questions, any designs, from the how-to and what we need to do for a bill of materials, let us know. To close, I want to basically quickly go through some of the other areas of Televic that has evolved rapidly over the last actually 1 to 2 years. So we do have a full software suite called Cocon. It does pretty much everything. But we also launched a browser-based control that's called Confero 360. And that means there's no computer to load or anything like that. If you have the IP of our engine and you have the license there with a password, you can dive in and boom, you have capabilities. One of which is microphone control. Again, we just talked about giving you the APIs to do it on any other way to do it, but this is the clean view of saying, I want to throw a diagram in there, have not only indicators, but these are microphone nodes that I can actually click on and control mics. So the end users really appreciate the clean look of saying, hey, this is nice. I can even throw a photograph of their room in there instead of a diagram, and they recognize, hey, that's where I sit. And somebody can turn my mic on or off. In addition to seeing the different modes, if you have it in a request to speak mode, you'll see who's speaking and who's waiting to speak, and moving things around. By the way, when we show this capability to the end user community in municipalities, cities, and states, they all kind of look at it going, wow, it's almost like you made this for us. And the answer is we did. That's all we do. We're a very good moderated meeting company. And that leads us to the next part, voting. We always tell everybody, don't assume that nobody votes or wants to. When they see how easy it can be, it's amazing. They go, ooh, we want that. So in this particular case, ad hoc quick voting, a floating bar, click on it, type in what you want to vote in, what is the topic, is it yes, no, abstain, and is it secret or not? And as soon as you say go, all the hardware starts blinking, and if it's not secret, you get an indicator that you can see live who's voting in what way. So this is the circle around their seat. So this is abstain, no, yes, abstain, yes, abstain, and a running tally until the voting's closed, and then here's the result and on with the meeting. The last component is simple reporting. We need to know who was in the meeting, when and where it was there an audio recording associated with it, and if there was a vote, what was the vote, what was the result, and if it wasn't secret, what was the breakdown of those votes. This is a package called Confero 360 that is growing in popularity, and the more people that see it at the end user level, the more they go, this is kind of like future proof, and we like the track of it is. From a technical side, however, it gives a lot of firepower to the person designing the room, implementing the room, and managing the room. So that's both of us on the integrator side and on the end user side. So I can anytime pop into the engine and see what's going on. I want to see the central unit. I want to see that I looped 5 units in this case, meaning it's a Cat5 from here to here to here to here to here and here. And if somebody disconnects or there's a bad cable here, the engine will see it and report it going, hey, you have a change here. In this case, we're okay because we looped it for redundancy, but we're still looking at now 2 branches coming off. But the warnings and errors are great. Warnings are a typical one for wireless. When there is a battery with less than 1 hour to go, a main warning will pop up here, and then the warning on the device so that you can actually say, oh, click on the halo, it's the 3rd row, 3rd guy, we need to replace his battery, plug it in the unit or whatever. So lots of flexibility, different modes. And I gotta tell you, the request to speak mode is growing rapidly because of COVID. So all of a sudden with Teams and Zoom and controlling the squares, managed meeting and changes have happened in 18 months faster than anticipated. So people are now looking at having a choice. Meaning it's not either or. Our systems, when they're put in, can be in direct speak mode, just like a DSP, or it could be, let's put it in and try out the request to speak mode where people have to wait. It's amazing the end users that we talk to on a regular basis that we really like to try this, and 80% of them love it, and then 20% have buyer's remorse and say, oh my gosh, we hated that. We have to go back to the other way. I wish we could. And we say, no problem. Go here, click, you're all better. And they can always try it later on again if a different administration comes in. So flexibility with our type. And then actually, I think you showed this in the APIs, Sean, but again, right click on any of the microphones and boost or cut the sensitivity of each microphone. The lean backers or the close talkers, we always have to worry about those guys. So in closing, I think that what is always the question is how would we attack this room from a DSP route, and what would be the difference? And having the home runs of the microphones to the DSP in addition to additional sources, having the gallery speakers in addition to the zone speakers above the dais if it's done correctly and additional outputs, but providing a Televic solution, providing those speakers in front of everybody is growing because of plexiglass, flexibility, extend the dais, go to another room, wired or wireless. It is really triggered something that the discussion microphone has become more valuable in our arsenal of AV solutions, more so than ever. And also coming soon, actually it's already launched, we can do demos for you right now, is a remote platform for municipalities and managed meetings. So in lieu of a Teams or a Zoom, let's control, the entire meeting for hybrid. Meaning if you enter into the demonstration with us and just sign up, and we can do those one-on-one with you, you will get an invite. It's just like anything else. Check your microphone and speaker, and boom, you're into the Televic platform. You'll notice that there's not a lot of squares that we do see with other platforms. That's kind of a distraction. So you see yourself and who is speaking. In addition, you get to see who's in the meeting, but if it's in request mode, which you can do, you have who's speaking and who's waiting to speak. The best part is that can extend from the room. So being able to say, I want those remote squares not to be able to just click and talk. Forget raising a hand. They can't talk until we say so. And then it says, you're the next speaker saying, hey, get ready. And when you go live, it's red. You're live with whomever's there, but you are sitting here just like you normally would. And then also voting, extended security voting. Being able to do this has gotten the attention of many markets in managed meetings. And there's many people excited to expand onto the system. So you'll notice that there's a little thing here saying, hey, remote guy, pay attention. There's a vote going on. Here's what you're voting on. You get a vote, confirm your vote. In addition to the agenda down here, you can click on it, see where you're at in the agenda, etc., and other features coming. So I guess today we did it in 46 minutes, so we're a little longer than I anticipated. I apologize, but a lot of flexibility we didn't talk about today: nameplates, dual and single-sided, RFID cards, automatic loading in, simple discussion systems, low profile with built-in recording, wired and wireless, different types of systems. This room is 110 microphones with one DSP and one echo canceller, and custom GUIs. We can do not only custom hardware, as I mentioned, but also custom software if needed, depending on the application. So I'd like to close there for questions, but we appreciate your time, and please provide us information on what you didn't see, what you hope to see. And we will be doing versions of this throughout the rest of the year as we expand with new features like Sean alluded to, mix minus mode, DSP mode, and others. So thank you very much. Dan, I'll give it to you for any last minute questions.
Yeah, we had one question come in. Do we have a list of TAA compliant products?
Yes, actually, that's a great question. We actually, all of our products are manufactured in Belgium and Bulgaria, which are TAA compliant countries. So the good news is we took it a step further. For those of you that work with military that require this, we even have a secure line where we pulled the radios out of our Flex unit and hard drive recording out of our engine, and we call it Flex S and AE-S. And that is something that is from a TAA compliant countries, no radios, so it works with Department of Defense and other related entities. And other countries are starting to pick up on that. So if you're from another country that requires that, please contact us and we will direct you to those models.
Okay. Sean, maybe one for you. Angel and Jose are asking if there's an API document for Confero 360.
Yes, so we do have a somewhat limited API at the moment for Confero 360, but it is available. If you send Dan your contact info, if he doesn't have it, I will email that document, or Dan will email that document over. We're also getting a more comprehensive Confero 360 API, just like the one we were talking about earlier for the kind of standard Plexus system that's going to be launching a little bit later this year. So answer is good one for now, better one coming a little bit later. But we'll send you what we've got now.
And for those of you that don't know the jargon, Confero 360 is our browser-based control software that I showed you. So again, Cocon, full-blown software, lives on a PC, does everything. Confero 360, browser-based with the features I showed you, and always evolving and expanding throughout the next year plus. Anything else, Dan?
I went ahead and typed Sean's email address into the chat window here. So if you'd like to request that API document, you can just shoot Sean an email and he'll reply right back to you. As of right now, there's no other questions outstanding. So if anybody has anything, feel free to start typing.
Right. And as we wait for the last minute, we appreciate your time. I think that we're excited to help and being part of the AV industry, especially in the United States. I really think it's interesting to hear the comments from our end users, like corporations, saying, you know what, I'm now remote. I know that everything's going to shift and we're going to have hybrid of some sort, but it's okay to have something on that conference room table because I'm home and I can't hear that room. And it's all about flexibility, whether it's divided rooms or the conference systems that, like can help with the traditional divided room scenario. Having that flexibility is really opened up to every vertical market except live performance. So healthcare, corporations, education, universities, having systems available in cases to pull around and have a meeting anywhere. On the simple side, we sell and support a number of systems for end users that basically said, we just want to hook up the Teams and Zoom, and meet in the gymnasium where we can all be, 20, 30 feet apart. And even though that was the last 18 months, that flexibility and that being able to do it in the future has really shown a new light. So we're doing our best to integrate. That's what today was all about. We hope that you can count on us for design and ideas. But Dan, any other questions, and we'll wrap it up.
We did have one question come in, which Sean typed an answer out to, but the question was on wireless systems. Do we need more than just the wireless access point and the desktop units? Is a central controller required? And the answer, of course, is that you don't necessarily need the separate controller. The WAP will suffice in a standalone wireless application.
Yeah, you know what's even more exciting? The G-Force system itself, that little white access point, the antennas are within the unit and multi-pattern. And you can plug a computer in there and also do Confero 360, so there's no engine needed. And you can use the G-Force system in a very simple way where you just hit the top button, and it's kind of like the open Sesame's door says, let's bring those units in. And you just you turn on the tabletop units, and on the display, you'll see a negotiation between a picture of the app and the unit, and a secure little badge comes up, and you know you're locked, and you hit the button on the access point, and you are locked those in, let's say to room A. Do the same thing in room B, room C, room D. And you don't even have to touch our GUI. So you can make it as simple as you want, extended as you want, flexible. Many applications also about extending wired and wireless, being able to say, I have a dais with wired units, but having a 10-pack in a case for extension in the room for ADA and special guests. But also we can take that case and roll it into a meeting area somewhere else in the jurisdiction. So universities, like I said, we're getting more and more discussions about how we could assist in the design of the future of the lecture hall because of remote participation. But again, we can go on and on. We just really appreciate your involvement of how we can expand with you. Anything else, Dan?
That looks to be it. I don't see anybody typing.
Okay. Well, great. Thank you, everyone. We appreciate your time, and we'll do this again. If you missed it or you need another colleague, we can do it one-on-one if necessary. Please contact us. Thanks, guys.